Mhm.
Okay. So this is the problem. Um, First unique character in a string. So what it's asking is, uh, we want to return the index of that character for which the first, for which, so basically we want to return the index of the character that's the first unique string. So first unique character. So that means there's no other characters in that string except for that one. There could be multiple uh, unique characters in a string, and we want to return the first one. So for instance, in the first example here, the first unique character is L because there's no other L's in the string. And then in this one here, it returns 2 because V is in the second index. And there's no other, well, there might be other, we all have another unique character, which is T, but it's not the first unique character. V would be the first unique character. And then in AABB, there are no unique characters, so we return -1. Feel free to think about this problem for a little bit, and if you have any like suggestions as to how to solve it, I can write it here, and we can like work through it together. So you can either like type in chat or say something, and we can solve it together. Do you guys have any ideas? Anu?
Yeah. So I was just thinking maybe you could do one pass through through the whole string and just put everything in some kind of dictionary. And
Okay.
then you can do a second pass through, and then the first time you, and then every time you check through the
Okay,
dictionary.
so when you pass through the dictionary, what do you want to do in your
Okay, so
first
what I
pass?
want to do is if the character isn't in the dictionary, you want to add it. If the character is in the dictionary, you want to put the, like, you want to store two things. You want to store the character and the count.
Mhm.
Um,
So what is the key
the
and the
character,
value?
the character,
Okay.
and the value is the count, as in like
Okay.
how many times it has showed up.
Mhm.
So in this case, yeah, exactly. And so then we're gonna do another pass through where the first time we see a character with a count of 1,
Mhm.
we want to return it. That's basically it. What I was thinking.
So in your second pass through,
Yeah, if the character, like the character has to be in the thing in the hash map because we went through it the first time. So you just check if the the value of that of the key the entry that has a key of that character has a value of 1, you want to return you want to return the index. Okay, I guess that is it. Oh,
so you would want to, so your for what kind of for loop would you do?
yeah, so you would do like for I in range of the length of the string. And so if yeah, instead of C, now it's going to be S brackets I, and if it equals 1, you return I.
Okay. Are there any other edge cases?
I guess if right, if there's nothing being returned, then I guess that is, you have to return -1. So I guess you could keep track with like a Boolean if something has been found, like some so the Boolean would initially be false, so like found or something.
Okay.
Um,
Okay. So what are you gonna do with this found
yeah,
variable?
so if we so if we sorry, since we're returning anyway, so it doesn't really, we can actually make it true. And then at the end, just So, sorry, we don't even need a Boolean. After the for loop, we can just return
Right, exactly.
because it's always gonna it should end after the for loop.
Exactly.
Yeah, so that
Right.
should be it.
Okay, nice. What's the time complexity?
So the first for loop is O of n because you just go through the whole what do you call it? The whole string where
Uh-huh.
the length of the string. And the second one is also O of n, so the total runtime should be O of n.
Okay, that's good. What about the memory complexity?
Yeah, the space complexity would be also O of n because you're storing everything in the hash map. So that would be my guess for the space complexity.
Maybe. So the answer is actually not O of n for memory
Okay.
complexity. Can you maybe think of a reason why?
Sorry, which one is not O of n? The space.
Right, the space complexity is not O of n. If you so look at the restrictions. S consists of only lowercase English letters. What does
I
that
guess
imply?
it's O of 1 because it's just going to be 26. 26.
Right, right, exactly.
Yeah.
And so here's a follow-up question. Say you could store like, say you had access to a database. How could you maybe improve the memory usage of this algorithm to make it truly O1? Because right now we're still it's O1, but we're still like creating a new like data structure, which is the hash map, right? So how would you take advantage of like a static piece of memory to improve the memory usage? Do you know what I mean?
I'm kind of sure what I think you're trying to say. Like we have a different, like instead of making our own hash map, if we can somehow use a static one that's already built for us.
Right. That's exactly what I'm saying. So you're like
Can
not
we
like
can we augment the static or no? No, right? Like we just have it as a reference.
yeah, you just have like a, how would you like initialize that hash map, I guess? Say it's stored somewhere like permanently. How would you initialize it?
How would I I guess if I had a different hat, like a more permanent, I would just put all the characters in, like all 26. I'm not sure what to do with the value of the keys. I don't know if I should just
maybe think of how like you're adding the values in the first place in this for loop. Like what is the definition of the hash map that contains your characters?
it's just gonna have a key value. It's gonna be a key value pair. The key is gonna be the character, and the value is the number of times it shows up.
Right. So we don't have a string, so we should set all values to be.
Oh, all values to be 0.
Right. Exactly. In this way, like you won't mess up, right? I mean, it could be any values, but.
Oh, I see. So you don't actually.
Right. You could say like, if well, in this case, C is definitely in string, right? You like, how would you like, instead of saying C is in string, you would say something like, sorry, this should be hash map, sorry for the confusion. You would say something like, if hash map of C is not equal to 0, right? Something like that. Or even you could even say like,
right,
or you can just increment, you can just remove like all this code, right?
Yeah, I understand. You don't even have to increment it every time. You just want to know if it's in your in your string. And so when you do the second pass through, as soon as you see the first unique character, then you should be good.
Exactly. So that we can actually simplify the problem even more if this is defined. If you set all the rows to 0,
Yeah, and
then
you
you
put in all
simplify
the
it even more.
characters, right? Okay.
Yeah. So that's like a typical follow-up question you would get in a interview. It's like a pop quiz sort of.
All right. Yeah.
Cool. Here's another follow-up question. Suppose that you have a user that wants to compute this problem a million times a day. What do you think would be an optimization that could compute this problem faster? So the user, for example, I want to compute and I give it LeetCode. Suppose I want to compute we know the time complexity is O of n, right? And if the user wants to compute it 1 million times, how would you improve the time complexity of this problem? So, yeah.
Okay.
I mean, not exactly the time complexity, but just the amount of time it takes, because the time complexity is still O of n, but you can make it a bit faster, like actually significantly faster, although the time complexity would still be the same, technically speaking. Like I'm a user and I compute this line of code 1 million times, and it takes O of n each time. Instead of making it O of n each time, I can just compute it once, store it in a hash map somewhere, and then I can say like, okay, I can say solution like this, right? And then I can say, okay, we know like what the problem is, and we can set the solutions of, for example, LeetCode to be equal to this thing, right? And now you're storing the solution of the actual problem in like a database or in a hash map. And then if the user wants to call it a million times, well, instead of computing the problem a million times,
Oh, sorry,
you
I
retrieve
understand.
it. Right.
It's the same problem a million times.
Exactly.
Okay, then yes, you would store it, and then you every time, instead of running the code, you could just return the value from the whatever you're storing it.
Exactly. There you go. That's one way to shorten the amount of time to solve like a scaling problem like this. Yeah, that's it for me. Thanks for participating. Hope you all learned something from me. Okay, Nisa, you're next.
Awesome. Thanks, Simon. That was really helpful. I'm just going to share my screen and let me know if you guys can see it. Oh, I have to open system preferences. Sorry. Okay. Okay, can you see my screen? Yeah, okay. So
Yeah.
I'm gonna read through the problem. We'll go through some of the example cases, and I was thinking that maybe we can split up into some breakout rooms, and then you guys can discuss the question for a few minutes, like 10 or 15 minutes, and then just try to go through it yourselves and then see what ideas you come up with, and then we can go through it together at the end. So the question is, given that you have an integer array called nums, you want to find the continuous non-empty subarray in your array that has the largest product, and you want to return that product. So you're not going to have integer overflow. The test cases are not going to do that. And then your subarray, just to clarify what a subarray is, it's just a continuous subsequence of an array. And so the example they give you over here is you have 2, 3, -2, 4. So your largest product is going to be 6 because 2 times 3, and you can't do 2 times 3 times -2 because your product is now -12, and that's smaller than 6. So 6 is the largest product you can get that's continuous, and you can't do like 2 times 3 times 4 because it's not continuous because the -2 is there. And then the same thing with the next one with -2, 0, and -1. The largest is 0, which is right here, because it can't be 2 because you can't do -2 and -1. So you have to make it 0. And yeah. Yeah, so that's pretty much the question. Do you guys want to split up into breakout rooms and try it out? And I'll be hopping in and out just to answer any questions if you have any. And then we can try the question together in a little bit. So I can open up the breakout rooms. Do you guys want like big groups or small groups? You can write in the chat or unmute yourself.
I think anything's fine.
Yeah.
Just like 3 groups or something.
Groups? Oh, okay. Okay. Open the rooms. I think everyone came back to the main room. So I overheard a lot of good discussion about how we could go through the problem. So before we start, I just wanted to go through. I know some breakout rooms came up with special edge cases. Were there any edge cases you guys wanted to share? We can like write them down and have them in mind before we start coding. You can raise your hand or unmute yourself or write them in the chat.
Yeah. I was gonna say an edge case is probably with if there's a negative at the as the first number and a negative as the last number,
Mhm.
and like and everything else is positive, then you want to take the whole array, just because it'd be positives, even though you start with a negative at the end, because of the negative at the end, you want to actually take the whole array rather than a subset of the array.
That's a good case. And then we can just make a random case like 2, 3, 4, 5, -6. That is an illustration of the example you gave us. And then are there any other cases anyone else has in mind?
Yeah, another one is what do you call it? Your max could be a 0.
Mhm.
And every number is a negative, and you just have 1 0, and that's the one you want to pick because the 0 is greater than all the negative numbers.
Yep, that's a good one. So we can have something like -7, -3, 0, -4, and then yep, your 0 is the max.
Well, in that case,
I that would not work.
the 21.
Yeah. Or I can like do a positive number there, or no, that won't work. No, that has to be it. Yeah, it has to be the test case. Is there anything else anyone else had in mind? No, if not, then we can get started. Before we actually code it out, I usually like to just like jot down what my ideas are, like kind of in pseudocode, and then go from there. Because that way, if I'm like going through the pseudocode, if I'm missing something or if I'm overlooking something, it's like helpful to like notice it before you write the whole code and then you have to erase it and then like start again. So I know a lot of groups had really good discussions about this. So does anyone want to guide me through a pseudocode of their implementation and then we can work from there? Well, if not, then I can get started with some ideas that I had. So what if we get started with the first index, and then we keep track of what our current maximum is so far, and then current minimum, and then just what our global type of maximum number is so far. And the reason we want to keep track of all these three things is because your global max will be like the actual big maximum that you're going to return at the end of your function. And then your current max is just going to keep track of the current maximum product that you have. And then your current minimum is going to keep track of the minimum, because if you have something like -7 right here, and if your next number is something like -1, your current minimum was a -7, and now it's a maximum because you multiplied it by another negative, so it becomes a positive. So we want to keep track of it for those reasons. And then, yeah, so I was thinking of keeping track of the global max, and then your current max, and then your current min. And then another thing is, yeah, after we keep that in mind, we just go through everything in the array, each element, and then from there we can just compare three things. So first we want to check before we do anything else to see if our element is a negative. And if it's a negative, then we need to swap our current max and current min, because like we saw earlier with the -7, if your next element, like instead of 0, if this was a -1, if this is a negative, your current min, which was -7, is now going to be a current max because it's +7. And then yeah, so you're just going to swap them, right? And then whatever you had before, whatever your previous max was, if there was something like 5 or whatever here, then your product now is going to be like flipped, right? And if you had like a +7, so you would have had a 35, and now you're at this term, and then that would be a -35. And if that was your current max, that becomes your current min. So you're just pretty much flipping whatever your max and mins are. So I'm just gonna do that. So we're just gonna check to see if the current element is negative. And then from there, yeah, we pretty much just compare the new product with the old product that we have, the current max, current min, and then we just take the maximum of whatever we have and set it as a global max. And then we just iterate through the rest of the items in our vector or array. And then from there, at the end of our for loop, we return whatever we're left with. So just iterate, and update global max. So then now that we have like kind of like an idea in mind, we can start coding. So we can have like an int global max, and we're just going to set that to the first element in the vector. Mistake that I usually make is I make it equal to 0, and that's bad because what if your whole vector is negatives? Like what if you have a array that's just -1? Your max would have been -1, but because you set it equal to 0, it's going to return 0. So that's a mistake that I make sometimes. So you got to be careful and make it the first element and not 0. So we're just going to make this nums at 0, and that's your first element. And then same thing with the current max and current min. We're just going to make them also equal to the first element for now. And then we can edit them later. And then we're just going to iterate through everything in our array. So we're just going to make a basic for loop. And we're just going to, or we're going to start at 1, sorry, because we already looked at index 0 right here. So if we look at it again and we multiply it again, your product's going to be bigger than it needs to be because you're counting the same element twice. You're multiplying it twice. So you don't want to start at 0. You want to start at 1. And then we're just going to go until the end of the array. So just nums.size. And then we're just going to increment I. And then the first thing we're going to do, going back to our pseudocode, we want to we kept track of that. Now we want to check to see if our current element is negative. So we're just going to check to see if nums at I is less than 0. And if it is, then we're just going to swap the max and the min because as we explained earlier, you need to swap them, otherwise it messes your thing up. So you're just going to have a temp, and that's just going to be per max. And then you're going to just swap the rest of them now, and then you're just going to do per max equal to per min. And then your per min is going to be equal to the temp. And then after you're done with that if statement, once you're done swapping the rest of them out, now you can pretty much just set your new current max and current mins. So you can make your current max the maximum of either the element you're looking at or the product, the previous max you had. Like for example, over here in this example, your previous max or min would have all been -7 because we originally made it index 0. So at that point, your maximum is -7. And then when you get here, your maximum is going to be whatever this is. But like instead of a 0, if this was a 2, your new product is -14, but your element is 2, right? Like at that index. So your maximum is going to be a 2. So you also want to consider just that one element at that index or the whole product or whatever your previous thing was as your maximum. So you have 3 possibilities. So we're going to consider that. So we're going to get the max of either your current max that you already have or your element that you're looking at right now. So that's just going to be nums at 0. And then we're also going to consider the product of them. So we're just going to do current max, or sorry, I don't think we even need to consider the only what you have because we consider it later on. So we're not even going to consider the previous current max. So we're just going to do current max times nums at 0. And then the same thing for the current min. We just do the min instead of the max of the things we're looking at. So the same reasoning as what we had earlier. We're just going to go through the current min and then times nums at 0, or that should be I, sorry, my bad. Nums at I, nums at I. And yeah, and then once we're done all that, we can just, again, increment or set our global max to be either the global max itself, if it's bigger than what we have, or we can set it to be the current max right there. So we're just going to do the max of either the current max or the global max, right? Does anyone have any questions with what we've done, or is anyone wondering anything, or yeah? If not, then I can run it. Let's see if we pass any of the test cases. Yeah.
Sorry, I just had a question. Why are you're swapping it every time you have a negative number, right? Like every time you see a negative number, even if you know you're not gonna pick it, I guess you always multiply it, right? So it doesn't really matter.
Yeah, because you always want you always want to multiply just in case you do have a bigger product. So I just thought we could swap it. But yeah. Do you guys want to manually go through a case, one of the example cases, or do you just want me to run the code?
I feel like it's better just to run it, see if it works.
Oh, I had a mistake.
Can you just iterate once more? Why do you keep the track of max and minimum?
Like over here in current max and current min?
Yeah.
Oh, okay. So the reasoning was if you have like an example like let's say -3.
Not that case. So we have 3 variables. One is the global max, that is for the maximum one. And the current max is for the current maximum till now. And the current min, why do we have the current min? I'm kind of confused here.
Something like this, like -3, and then we're gonna look at something like -1, and then yeah, that should be it. Yeah, and then let's just say we have something like 2. So if you look at your product, so for like, let's say you're looking at this index right now, you're looking at -1. So your product so far would be a -6, right? And your maximum product is a 2, and then your product so far is a -6. And then you're looking at this element, and then you're going to remember that you had a -6, but that's like your minimum. And then when you multiply that -6 by a -1, you get a +6, right? So then that's your new maximum. So then you don't really care about the old maximum, which was a 2. You want to remember the new maximum, which is a 6, right?
Okay, yeah, got
Does
it.
that make sense?
Yes.
Yeah, okay. And then I forgot to return our global max, so I should do that. Let's hope this compiles. Okay, and then if we just test it against everything. Yeah, when I tried it earlier, I got the wrong answer because I set my original variables to 0, not nums add 0. So that's what I usually do. And then we noticed that our thing is only faster than 56.87% of submissions. Is there anything that you guys suggest we could do to like maybe optimize this a little bit more?
Yeah, maybe. Oh, actually, I was gonna say maybe you don't have to swap every time. But if as soon as you see a negative number, maybe you don't have to swap. Maybe there's a way to tell if you have to swap or not.
Was
But
there
not-
anything you were, yeah, was there any specific way to tell like that you had in mind and we can test that out?
No, I was still thinking about it to see if there was a way to not get it to swap. But I'm not super sure.
But if you want to throw anything out there, we can give it a try. But yeah, if you guys want to think about it for a little bit, we can think about that. And then while you're thinking, do you have any idea of what the runtime complexity could be?
Well, since it's just a single for loop and you're really just doing like constant work at each one, should be O of n. But
Yep, it's O of n. And then do you know what the space complexity could be?
should be, I was gonna say O of 1, just because you only have 3 variables and you're not, you don't have like an array of stored values or anything.
Yep. So O of 1 for space, because yep, like as you said, we don't have any array or anything that we're making. We just have our 3 variables. And then our runtime is O of n because yeah, we're just going through the for loop one time. But yeah, if we want to try to maybe optimize the negative condition here, I don't know, something we can do is we can check this thing over here first, and then maybe we can try to swap later if it makes a difference. We can give that a try, and then some other things, maybe instead of swapping every time, we only check that. And then yeah, I think that's pretty much all. I can't think of anything else, but if anyone else has any suggestions, yeah, you can write them in the chat or unmute yourself.
Yeah, you could run current max and current min before your swap and then check if current min is greater than current max and swap the two.
Okay, yeah, I like that. Let's give that a try. So we're gonna run this first. And then, so if current max is less than current min, then we're just gonna swap them. So use the temp here. And okay, let's give that a try. Right, and then let's submit that. Oh, so for this test case, didn't go through. So I think we can't swap them before. I think we have to do the negative swap first and then swap them after, because I think the reasoning is if you do have like a negative, like over here, when you have a -2 and then 3, and then the -4 after. So at this point, if you're looking at the -4, you have the -2 and then 3, that gives you a -6. And then, right? And then you look at the -6, or that's your current min, -6 times whatever your thing is, so -4. But for the current max, your current max is still a 3, not a 6, right? Because you didn't swap them before. Yeah, but that was a good idea. I like that. That was a good suggestion. But yeah, so if anyone else has any questions about this question or anything else that they want to ask me, yeah, I'm here. Yeah, I'll stop sharing my screen then if no one has any questions. I like the question in the chat. Someone asked if it's better to try to optimize it or use a brute force approach. I think that's a really good question because what I do personally is like I like try to write out like pseudocode, and like sometimes if I don't really know what the most optimal approach is, I will literally just like like try to brute force it, even if it's like O(n) squared or O(n) cubed, like just try to get some idea out there. And then from there, you might be able to find like a better optimal way. But if you already know the optimal solution, I think it's important just to just briefly mention the brute force way, and then from there you can just go into the optimal solution. But yeah, so just in case you're not able to, for whatever reason, code out the optimal solution, you can always go back to the brute force solution. But yeah, thanks for the question. That was a good question. Does anyone else have any questions for me? So if not, thanks for coming out. It was nice doing the question with you guys today. And if you have any questions for me, you can reach out to me via LinkedIn or Instagram or Discord. I'm a VP at Data Science Club, so you can find me in the Data Science Discord. And yeah, thanks for coming out.